So hi everyone, thanks for sort of joining or for watching this video. So my name's Olivia and I work for an organisation called the Southeast Physics Network. And I work in a field currently called Outreach and Public Engagement. So I'll sort of tell you a bit about that, tell you a bit about me, and then my kind of journey for getting here as well. So what do I do? What is outreach and public engagement? They're likely words you may not have heard of, or you might have heard of in sort of specific contexts. So I work for an organisation called the Southeast Physics Network, and we're basically a collaboration of 10 university physics departments across the southeast of England, and we sort of all work together to achieve set goals. And one of those is our outreach and public engagement programme. So kind of split that into two. Outreach involves working with young people, school and families, and we basically want to share that physics is fun and open to all. I'm a physicist, I did a physics degree, I've actually got a PhD as well, I'll talk about that in a minute, and then I've sort of got into this field after, and I love physics, and I just sort of want more people, more young people to have the option to study physics and take it further and see, you know, what they enjoy about it. The other kind of side of what I do now is public engagement. So this is working with the researchers, the academics and universities, and firstly, we want to involve public in their research as much as possible. So you might have heard of things like Galaxy Zoo, which is a project run by Oxford University. So that's where anyone can just log onto a website and classify galaxies based on how they look, and you're inputting into the research in that way. There's also lots of projects around where people at home can help identify exoplanets. So they look for things like how much the light of a star dims and then brightens again when a planet sort of crosses in front of it. And you can do that literally at home with a laptop, with a mobile phone, and you're doing the research. So that's kind of really cool, getting just publics involved in the research. The other part is just helping the academics communicate and explain their research. Lots of academics are really good at this, some are less good. I'm sure you've all seen documentaries and news and things where someone maybe has not explained something in a really open and accessible way. So we kind of try and make sure that academics can explain what they're doing, what they're working on and what they're finding out basically in physics. I've just included like a few images here to give you kind of an idea of my day to day. So a couple of these are from kind of outreach and type events. The bottom left one is from an event at the Royal Society. This was pre-COVID, a couple of years ago. So talking about the moon and all the research that we do at the Open University on the moon. A project I particularly like, you can see a small image there, which has got kind of two squares, and it's actually a picture of a galaxy, and the next to it you can see kind of, it's like a bumpy square basically. So that's a 3D printed image of the same galaxy. And this is a project run out of Portsmouth University called Tactile Universe, and this enables visually impaired people to engage with astronomy. So this was set up by a colleague of mine, Nick Bond, who was absolutely awesome. He's a visually impaired astronomer himself, and he was just annoyed because he'd been through his whole educational career without having resources he could use to help his learning. So yeah, we've created a whole bunch of resources, and they're really fantastic. So I'm going to sort of go back to the start, kind of what got me into physics, what did I enjoy doing when I was at school? So I've just bunged over a few really basic images here. The thing that got me into physics as a broader subject was astronomy. I loved astronomy from about the age of 9 or 10. And I had a really fantastic primary school teacher who was one of these guys who was just interested in everything from Henry VIII to the planets and everything in between. And he sort of taught us, you know, the tiny bit of astronomy that's in the year 5-ish curriculum, or certainly was then. And it just really sparked my enthusiasm, and he was willing to have lots of conversations with me about it. I think I asked my parents for a telescope for Christmas, and that kind of passion never died. And that's what drove me to be more interested in physics and science, was actually that kind of interest in the universe and the stars and kind of how that all works, because to me that's kind of baffling and mind-boggling. The other kind of things I'm interested in, or especially was at school, reading. I mean, I'm still really interested in reading. You'll never find me without a book. The Harry Potter series kind of summed me up growing up. But more or less anything and everything. I really like literature, and similarly, I used to be really involved in sort of drama and things. Less so now, but I'm looking to get kind of back into it, especially post-COVID. Lots of things haven't been running the last couple of years. And especially in school, I was quite sporty. I used to play for a girls' football team, and now I run quite a lot. So these are the kind of things I sort of enjoyed, and I still enjoy, and I think actually kind of helped me get to where I am today. So as you know, I have the physics background, But the job I'm in now is quite about working with people and communicating. And I think the fact I really enjoyed the kind of arts type side of things as well has really helped with that. So for my A levels, I did maths, further maths, physics, and English literature, which is quite an unusual mix. And I think that's kind of really helped me with the kind of communication side of what I'm doing, that I have a bit more of the arts background than maybe some people who go into sciences. I think I mentioned I did a PhD, so I'll talk to you a bit about that, because that ties in really well with obviously the space theme of this World Space Week, of World Space Week. So yeah, I did my physics degree and then I went on to do a PhD. So what a PhD is it's like a higher level degree, but really it's just doing a 3 or 4 year long piece of research. So you pick a topic you're interested in, or you go to university where they already study a topic you're interested in, and you just get to research it, look into it. And I did this on astronomy, so galaxies in particular. So we live in a galaxy called the Milky Way, but there are billions and billions of other galaxies out in space, and I was looking at other ones, not ours. It was really great fun. I got to go to Australia and use a big radio telescope. So there's a picture of me in Australia. That was run up to Christmas a few years ago, and it was absolutely boiling and really weird because everything was decorated for Christmas, but it was like 30 degrees. Very strange. And what I looked at doing this PhD was sort of other galaxies, and especially the gas in them. So using radio telescopes, we can look at the gas in other galaxies rather than the stars. And you're probably thinking, why would you want to do that? The stars are the interesting bit. Well, it's all the interesting bit, and the gas is what goes to form stars. So basically when gas gets really close together and it gets built at really high pressure, it heats up and it makes a star. That's what the sun is. It's basically a big ball of burning gas. So to look at galaxies, you have to understand their gas as well as their stars, because it can tell you where new stars might form. It might tell you where stars have sort of died and they blow things out. When they die, they kind of explode, which is quite cool. And this kind of video on the left, this is actually a picture of a galaxy in gas. So it looks a bit confusing, but basically the weird blobby thing in the middle, that's the galaxy. So that galaxy is called M33, and the bottom right picture is of that galaxy in stars, a more normal picture. And the gas basically told me how that galaxy was moving, how it was interacting, and it told me if there was other structures near the galaxy that we couldn't see in stars. So you can see sort of on this, just behind it, there's some red fuzzy blobby things again, and those are kind of big gas clouds behind the galaxy that you can't see in stars but are there in gas. So that's what I was looking at for my PhD. I found it really, really interesting. I found research interesting. However, I thought, well, maybe that's not the career for me long term, so I sort of moved out of it. So I'll sort of show you a little bit about my rather potted career path. So after school, I went to initially the University of Southampton, and I did a degree which was called an MPhys with astronomy. All that means is it was a physics degree, and I specialised with astronomy, so I sort of did more astronomy modules than I did anything else, but I did most of it was just core physics. And the MPhys means I did a 4-year degree, so you get what's called a combined master's. So you just do a bit more research and things in the 4th year. And that works quite well if you think you might be interested in going into research or working in kind of business and industry, which is really kind of hands-on science and physics. Doing that extra year can be quite useful. During that, I did lots of outreach and things. So I went out with something called the Soton Astrodome, which was an inflatable planetarium, and I went out to lots of schools and talked to people about science. There's a picture of me just at the top of this here playing with liquid nitrogen. So we used to use liquid nitrogen a lot in sort of shows to talk to schools and things about science. And during that time, I also did like an industrial work placement over a summer with a company called Selex Galileo. I think they've renamed themselves to Leonardo now, but they were called Selex Galileo then. And they make like infrared cameras, so cameras that detect heat for all sorts of purposes, but one of those purposes is space. So they're sending them up on satellites, and they're using these to look back at the Earth and look at bits of the Earth that are really hot and really cold, and sort of work out what that means and why things are the temperatures they are, basically. So that was really interesting. That was in a kind of a lab setting. I was using electronic equipment to do sort of testing and things every day. And that just gave me kind of a really different insight into a different type of science and a different type of career. And I'd certainly recommend, if you're interested in, whatever you're interested going forward, try and do some things like that. Try and do work experience placements to get an idea of different jobs in different industries that you might be interested in going into. So at the end of my undergrad degree, I went on, as I mentioned, to do the PhD. I went to Cardiff University for that because they were doing the sort of science I was interested in. Cardiff's also a great city. Recommend living there for a few years if you get the chance. And while I was doing that PhD, I did lots of sort of other things on the side. So I carried on doing sort of outreachy things. I became a member of the Institute of Physics, and they have loads of really cool opportunities if you're studying physics or related subjects, and for you to sort of go to conferences, workshops, just get to meet other people and talk to them a bit, really. I sort of wrote for some magazines. So one of them, it was called Room, the Space Journal. So I wrote about the research I was doing and sort of had that put out more to public audiences. And then I kind of came to the end of that PhD, and I looked back at all the things I'd done and what I really enjoyed. And I knew I enjoyed working in universities with research. I wasn't too fussed about doing the research myself, but I really enjoyed doing that communication and that kind of outreach work I've been doing. So that's then what I ended up going in to do. So I became, the first job out of my PhD was working for the Institute of Physics, I've already mentioned. So they're a learned society who represent physicists. And I worked in outreach and engagement for them and managing their activities across the Southeast region. And this was really, really fun. I worked with loads of members who were all physicists. We went and we communicated physics, we talked to people about physics, and we ran sort of programs to get more young people, and especially more young people who aren't so represented in physics. So there's lots of sort of white men in physics. That's very stereotypical. If you think of a physicist, you probably think of Einstein. There's fewer women and there's fewer people of colour. So we're working really hard with those communities to try and encourage some of those into physics, because we really need them. We need their voices, we need their skills. And the numbers are gradually picking up, which is really great. But we need to continue working with these groups. So yeah, that's what I did. I worked for the Institute of Physics for a few years, and then I moved on to the job I'm in now, which I told you a bit about at the start, working across all these universities in the Southeast with sort of schools and young people and with publics, talking about research. I think the main thing I've learned from this, and I think which I kind of hope is quite general advice for whatever you're interested in doing, is to sort of say yes to things. If opportunities come up and you think they might be interesting, if you can, if you've got the means, if you've got the ability to take up the time, just try and say yes to things and try them out, because you don't know what you'll enjoy really till you've tried it. And I think even if you have a really strong idea of what you might want to do sort of 10-20 years down the line, that might change. You might start doing that as a job, like I did with research. I did enjoy it, but I knew it wasn't what I wanted to do for the rest of my life. So I think when other opportunities come up, take them, try things out, and just see what you really enjoy, and then find a career route that fits like that. Just as a sort of a more general overview of what sort of physics graduates go on to do after doing a physics degree, if you're interested in doing a physics degree. So 25% go to further study. So that's, like I mentioned before, something might be like a PhD or a freestanding master's. And then of the rest, I've kind of broken it down into a little pie chart here. So about 32% work as IT professionals. So that's a huge range of things. And a lot of it nowadays is things like data science, machine learning, coding. Loads of people go into this for all different purposes. I mean, lots of it is used in the space industry as well. So there are the people who basically sit on Earth and control all the satellites and things do, which is really cool. About 13% of people go into business and finance, and so go into things like banking, accountancy, analytics, all this kind of stuff. About 25% into manufacturing and construction, so a lot of that will be engineering linked careers, so building stuff and making sure it doesn't fall down. And similarly, you can do that either on Earth, or you can basically build stuff to send to space. You can build like rockets and space probes and all this kind of stuff. About 8% is what we call science professionals. So that's more your people kind of work in university or work in laboratories doing like pure research. And then about 8% into education. So that's sort of school, teaching at universities, that kind of those kind of jobs. I think looking at this often surprises people, because I think people hear the word physics and assume that everyone comes out at the end and they're just, again, a bit of an Einstein working in a lab, and that's what they do. So most people with a physics degree don't physics degrees open so many doors, especially in terms of giving you really high analytical skills, computational skills, and most companies are crying out for people with these skills. So if you're interested in physics, it's definitely a good degree to do if you want to go to university, sort of regardless as if you don't know the end goal, because it just opens so many doors for you. Okay, so I think I'm sort of running low on time, so I'm going to stop here and just see if there's any questions to take now, which I'm happy to do.
Hi, Olivia. It looks like we're a bit shy. I have posted in the queue in the announcements that people can ask questions if they'd like to, but at the moment they're quite shy. So if you're happy to carry on with your presentation, that would be great.
Sure, yeah. So all I've got now, I can just go over a few sort of careers from physics you can do with different levels of qualifications. So yeah, this is a set of resources actually I built up through working for SEPnet. So we wanted a set of really easy resources that can give people an idea of the scope of careers they can go into, and also the level of physics needed, because not every career using physics needs a physics degree. If university is not for you, that's absolutely fine. There's lots of different levels of entry and different qualifications, and then you can get sort of trained up on jobs. So I'll just sort of highlight a few of these. One of them's an electrical engineer. So again, people may think of jobs like this as needing a degree in engineering or electronics. Not at all. At the entry level, you can kind of go in with whatever background. The level of, as you can see on here, the level of this you can enter as an apprentice, which basically means you can you can enter from school. You don't even need A levels. You can just sort of do your schooling up to the end of GCSE, and then you can get an apprenticeship with companies to work as an electrical engineer. So we've named sort of one employer that's in kind of our region that does this, but there's a bunch of employers. So if you sort of were interested in something like this, it's worth having a search. So electrical engineers, they build and maintain electrical components, and they make sure everything's safe and working well. And we kind of highlight some key skills, because I think people always think of these jobs as just needing people to be super mathematical or super brainy. But to work in electricity, you need to be really creative. You need to think how things might go together, and you need to also be logical and collaborative, because as we said, you need to sort of keep safe doing stuff with electronics. So you want to make sure that you're communicating well with the team and people around you, and that you're on the same page doing things. So this is definitely a job where physics and a physics background is useful, but it's definitely, you can come at this from lots of different angles, from maths, from engineering, and it's one that you do not need to go to university for. So if university doesn't feel for you, this might be something to look into that you can do. You can get trained up sort of through a company on the job effectively. Another one people don't realise actually a lot of physicists go on to do is be a games designer. So games designers obviously is a lot of coding, a lot of computer skills. That's effectively what we use very heavily in physics. We model things, we create like models and computer simulations of things in physics to test them, and we use computer code to do that. So through doing sort of physics and studying physics, you tend to get a lot of this experience. This is one where it's useful to have an undergrad or master's degree, again, just to build up that coding experience, but you can also do loads if there's online courses and things in coding if you're interested to do stuff like that. Again, we've sort of mentioned a local employer, but there's absolutely loads of people employing people to do games design, and yeah, a surprising amount of them have physics backgrounds. The next one is maybe a more obvious one from physics. So this, as I mentioned, this is sort of what I did for a while, so being an astronomer. So astronomers study how the universe works effectively, and if we compare it, astronomers compare it to how we predict it works based on the physics we know, and then we try and see if the difference is something physical. So is there something we can't see yet with our telescopes, or is there a problem with our understanding of the universe, and do we need to revisit our models, which we do a lot. This is one that needs physics. You need to sort of have a physics background to do this, and you need a kind of higher level degree to go into this. So this is one you sort of definitely go through the very traditional university pathway and get then a master's or PhD degree to progress into doing sort of astronomy research. The sort of last one I've got for you is again a really different one. So you may well not know that an awful lot of people with sort of physics backgrounds are involved in food design and manufacture. It's about working out sort of how foods work, how they interact with bodies, making sure they're safely produced, making sure they're sort of safely packaged in ways that sort of keep the food fresh, doing things like environmental packaging, making sure that the packaging isn't damaging the planet we live on, because we know that that's a big problem we have with like overuse of plastics, for example. This is a great one that uses so many transferable skills from physics, and an awful lot of food companies are crying out for people with physics backgrounds to come and work for them, because they kind of want their unique take on things and their skills. So this is one it's handy to have an undergraduate level degree to go into. But again, it's just another example of the kind of broad amount of things you can do from physics. Okay, great. I just wanted to give you a bit of an overview of lots of different things you can do with physics skills. So I'll kind of stop talking and see if we've got any questions coming in.